Good afternoon to all. I am Professor Aashish Gadgil. I'll be presenting before you the overview of the subject Embedded System Design with our course code 18DC 663, which is the open elective offered by the Department of EHC. So here today you'll be seeing some of the concepts of embedded systems, various examples, and a bit of processors which are being used, and what are the software which is used for it, along with the syllabus, and then we'll be seeing the companies which offer jobs for embedded system engineers. So what is an embedded system? So embedded system is a system whose principal function is not computational, but actually it is controlled by a computer which is embedded within it. There is no just a single definition for embedded system. So it could also be called as a combination of hardware and software designed to perform a dedicated function. So most of the time embedded systems are designed with a single purpose in mind. So embedded systems are most of the times are part of a larger system or product. So example of this could be an anti-lock braking system or ABS, which you are commonly know in case of car. Embedded systems are again tightly coupled to the environment. That means that they actually impose real-time constraints or on the real-time requirements for the task to complete. Now, if we take various examples, a simple example like a refrigerator. So if you see here, there are various things which are going on. Like in case of a refrigerator, you have a compressor control, you have an alarm, then there is a display. Then you will get to see actual temperature, then you set the required temperature. So all of these things are taken care by just a single chip, which is present in the refrigerator, which is your embedded computer. Another example could be your car door. So in case of a car door, you have various sensors which are present. Like you have a window stall sensor, then the window control buttons. There are various motors for operating it. So the lock control actuator, then the open door sensor. So actually all of this actually forms a embedded system. And in car, in an automobile in particularly, there are various or huge number of embedded systems which are present. This is car door is just one among. Then this is just an example showing of how a game could be implemented as an embedded system. So it's an electronic ping pong. So a single chip here is performing the entire operation of a game being implemented. So there are scoring LEDs, then there is a player 1, 2 and paddle. There is a on a switch, so once you start, the game automatically starts. Then this is an example of a Durbot autonomous guided vehicle. So now, although this is a robot, it is actually nothing but an embedded system. So there is an ultrasonic sensor, then there are motor drives, wheels, batteries, and there are again various sensors which are present. So there could be a bump sensor which is detecting bumps. So accordingly, the vehicle, it determines whether the vehicle should proceed further or not. So if you see the block diagram approach of this, so you have a bump sensor as I was telling you, then you have a light sensor, then you have, of course, you have a power, then a motor drive to operate the vehicle wheels. Then you have an ultrasonic ranging module which determines how much is the distance between a particular obstacle and a vehicle. And the heart, you have a processor which is nothing but a microcontroller. So here in this scenario, a PIC microcontroller is being used. Then the various industry sectors and examples of the various embedded devices which are present in it. So you can see as per the market trends, embedded systems are present in most of the sectors related of whichever sector you consider. So it's whether it's automotive, consumer electronics, industrial control, even in medical field, and various office automation. So if you see in automotive, you have a ignition system, engine control, brake system. Then in consumer electronics, you have your digital and analog TVs, then set-top boxes which are commonly used nowadays. Then kitchen appliances like you have refrigerators, microwave ovens, automobiles, cameras. Then industrial control, so where your robotics and control systems are present. Then medical fields, where you have your infusion pumps, then the dialysis machine, cardiac monitors. In all these, even in medical fields, embedded devices are present nowadays. Then you have various office automation, wherein you have your printers, monitors, scanners. So in all of these, actually, what you get is the embedded system. And that is what you will be learning as part of this syllabus or the subject. So then the various computer essentials which are necessary for the embedded system. So you generally have the outside world interacting with the system. So you have an input-output device, then there is a processing unit, and you have a program and data memory. So accordingly, the interaction can happen depending on what is the application. Then there are various instruction sets again. So mostly the computer science graduates will relate more to this. So you have a CISC and a RISC, that is complex instruction set computer, and a reduced instruction set computer. And then there are various memory types where you have a random access memory or read-only memory. Your read-only memory is nothing but your regular hard disk, which is does not which retains the data even after the power of the power even after power of a machine. Then you have von Neumann and Harvard computers. So as now most of the computers come with Harvard architecture itself. That is there is a separate data bus for accessing the address as well as data simultaneously. Then the heart of the any embedded system is a processor or a processing unit. It can be either a microprocessor or a microcontroller. So microprocessor is a processor on a single electron chip, and the microcontrollers are used in embedded computing. So the microcontroller is actually a processor, but with additional circuitry added onto it. So if you check the differences between a microprocessor and a microcontroller, your CPU is standalone in case of a microprocessor. RAM, ROM, and other peripherals are separate. Whereas these, in case of microcontroller, they come on chip as a single chip. So in microprocessor, designer can decide what will be the amount of RAM, ROM. Whereas in microcontroller, it's a fixed amount of on-chip RAM, ROM. The microprocessor could be used. It's expansive, it is versatile, and mainly it is general purpose. But microcontroller is used for applications which are in which cost, power, and space are critical, and it is used most of the times for single function. So that is what is the requirement of an embedded system. It's used for a single functionality. So depending on the different types of microcontrollers, this is just general architecture. Different types of microcontroller or different families of microcontroller will have the same thing, but they vary in quantity. So if you see the packaging, you have come from a long way right now, from a small chip to a very large chip. So if you check an example, it could be a PIC, which is by Microchip Industries, to Motorola. So I think most of the people know Motorola nowadays. So they also manufacture chips which are nothing but embedded devices. Next, when we talk about real time, when we talk about embedded systems, we are always talking about real time. So every real time system is an embedded system, but the vice versa is not always true. And the software which takes care of real time systems is your real time operating system. So it provides the capability to perform a task in a very stipulated time, or you can say it provides a bounded response time. So RTOS is or RTOS is an abstraction from hardware and software programming, and choosing it is very important because it depends on porting, and in embedded system the cost is of prime importance whenever you are designing an embedded system. However, real time does not mean speed, but it means keeping to the deadlines, or you can say finishing a task within a particular time frame, and thus it provides deterministic behavior, and the response and reaction times are very small. Then real-time languages and OS. So typical OS configuration is this. You can see the user programs, then there is an operating system and hardware. Whereas for embedded configuration, your user programs, including operating system components, there is a single layer and there is a hardware. So you have a software which is controlling the hardware. Then typical topics of interest in real-time system are that they need to have a deterministic response time. So the response time should be deterministic, and it should not vary from one application to the other. So then this is one of the common usage of real-time systems, wherein it refers to a 4 KB OS that creates a schedule primitive task by absolute priorities and responds immediately to hardware interrupts, but it does not do anything else. So it does very little else. So this is useful for simple applications that gather instrumentation signals or control industrial processes. Now, when we talk about real-time system is one of the system in which the correctness of the computations does not depend upon just the logical correctness of the output, or it also depends on the time at which the result is produced. So if the timing constraint is lost, then you can say that the system has failed. So depending on that, the real-time systems are classified into two, either hard real-time systems or soft real-time systems. In case of soft real-time systems, the requirements are less severe. Again, there are different terminologies which can be used. So hard real-time system is nothing but a flight control system, wherein the deadline is cannot be missed under any circumstances. Your soft real-time systems are your data acquisition systems. Then there is a real-time category wherein these are systems which are hard real-time, but their response times need to be very small. So your typical missile guidance system comes under this category, and there is a firm real-time system also. So a single system now may have all the hard, soft, and real-time subsystems within it. Generally, what happens is a cost function is associated with missing each of the deadlines. Now, there are various requirements for a soft and hard real-time system. So, in the case of soft real-time system, breaking the time limit is unwanted, but is not critical immediately. So, your multimedia streaming applications come under this. Whereas a hard real-time system is wherein breaking the limit will cause ultimately to a failure. So for a nuclear power plant controller, that is your hard real-time system. So even in case of a nuclear power plant, there are various embedded systems which are present, and they control the functioning of the plant. Then the hard real-time system guarantees you worst-case response times, and they are absolutely positive first time every time. And soft, it kind of guarantees that it provides the best possible service, but does not guarantee that it will meet the deadlines under any circumstances. Now, the real-time applications are the one which are most familiar for this purpose are various business applications. They require high performance embedded applications and these are embedded applications that are often called upon to manage time-critical responses. Now, the most demanding of these applications they are most demanding of these applications and not only need to respond correctly, but also need to respond within a certain specified time and in real time. So, some of the examples here could include the manufacturing process controls, medical monitoring equipment, then your telecommunication switching equipment, high-speed data acquisition systems, and even an aircraft. So, whenever you have an embedded system, there are generally, or any system, in example, you have OS which controls the functioning of the system. So it could be a general purpose OS, or in case of embedded system, it's an embedded OS. So some of the criteria are mentioned. Like you have in general purpose could be Linux and Windows, whereas in embedded OS is Windows CE and Palm OS. And hardware, you can see general purpose is used for general purpose, but embedded OS is used for a specific device purpose. And OS code, stability requirement, and development cost accordingly are mentioned for both of them. Now, there are some various examples for embedded systems. So, one of them is wireless communications. In that scenario, handheld GPS units are again a type of embedded system. Your telematics system, which is present for automobiles, is another one where you can see various types of telematics. You can get information about the weather. All of these are actually nothing but embedded systems. Another part of this could be robotics control. So this is an example of a spider robot, which is constructed with Lego Mindstorm components. So this is in fact nothing but actually an embedded system. Then again, smart toys. So this is an example of building a smart toy, which is a smart dog example. So you can design such things once you have a knowledge about embedded systems and how to design an embedded system. Then your cruise guidance, missile guidance again comes a part of this. The controlling part of this, and there is an embedded device present in it, due to which this actual missile guidance system works. So this is again a part of an application of an embedded system. If now this is a picture of a car. You can see there are these many embedded systems present within a car, or embedded devices which is present in the car. So as we were discussing, your embedded systems are part of a larger product or larger system, So car as a system, you can imagine, and there are so many embedded devices within a car alone. So if you imagine your home, so if you take out some of the devices, you can actually have these many devices which are embedded or embedded applications. So whenever you have an embedded system, it's nothing but a computer inside a product. So it could be a wind turbine, there could be aircraft, navigation, then your malls, trains, then your key which you use for unlocking the car. Actually, it's an embedded device. So this is the short list of embedded systems. And I'm saying this is the short list. So you can see how many have been listed. And even after this, it's a short list. So particular what we will be focusing on is the design with the focus on application and not just theoretical aspects. So technology is actually not the end. It is actually a means. So it's a goal is to solve highly constrained problems. So this is the example of a soybean farmer who realized who created a computer to create images that show the plots where more fertilizer or pesticide is needed. So this is where what he actually has developed is an embedded device. So this is where the knowledge of this subject is essential. So the future of embedded system is, you can see the sewing machine could be different. Then it could be transportation, consumer electronics, concrete sensors. So it could also be embedded in clothing nowadays. Then there is communication and translation. Then there is a computer fridge. So generally every time you hear about a far-fetched idea, you can find a web page with a photo of a prototype or a product. So that is nothing but a digital frying pan and an embedded web server. So these are all your embedded systems. Then your future of the embedded system could be, you have an interactive media, then energy management, then HVAC systems, voice over diagnostics, all of this public internet going through a gateway operator to your home, where you can use keypad, PC to do climate control, refrigerator, TV control, and actually have your smart homes. So whether the people will be ready to adopt this as a toy. But this is possible if we make the system readily accessible, reliable, and affordable. And once we make this, the possibilities are almost endless. So as a syllabus, what we will be studying in this subject is, we will be firstly having introduction to the embedded systems, then the hardware software co-design, then how the communication takes place in case of an embedded system, then your real-time operating system, which is the controlling part of the embedded system, and at the end we will be learning embedded C, so which is another industrial standard due to which it has been included in the syllabus. Then there are various companies offering job to the embedded engineers. So Intel, IBM, Philips, Motorola, Texas Instruments, Volvo, all of this come under it. Again, various other companies are also been mentioned, like Bosch, Mercedes, Benz, then L&T, then Harman. So there are various other Tata Elxsi, these are mentioned. So there is another few. So you will get job if you are having a knowledge about embedded in these companies. So lastly, what I can tell you is, whenever you go in for jobs and get placed in companies, either you will be designing an embedded system wherein you will be working on a hardware part, or you will be writing a software for a particular embedded systems. Hence, the subject is much more essential, and it could be of great use to you once you go into the companies or during getting placed in the companies also. Thank you. Hope to see you in the class. Happy learning. Thank you. Number 944 9292 9292 671. माझा मोबाईल कुठे मिळेल ते राहून देत तुम्हाला मोबाईल.
अरे कदम सर कॉल केलेला आहे. हा कुणाचा आहे माहिती नाही यायला. हा हा प्रेझेंटेशन मोड मध्ये जाऊ काय?
थोडा वेळासाठी नंतर
कॅमेरा ऑफ करू.
your entire
कॅमेरा ऑफ करतो पहिला.
हा चालतंय. एक मिनिट इकडे your entire
स्क्रीन
हा इथेच share.
नाही, मध्ये मध्ये मला PDF ओपन करायला पाहिजे ते, म्हणून म्हटलं. हे असं कुठं आहे? नाहीतर इथं हे बघतो. या सिस्टमचं हे कुठं आहे?
इकडे
येत नाही. याला CPU
नाही
कारण हे मध्ये मध्ये PPT बघायला, हे PDF बघायचं होतं मला प्रेझेंटेशन चालू असताना. त्याच्या ह्याच्याने मी आलेलो.
लाईव्ह झालंय सर.
ठीक आहे, या साईडला चालते.
करून देऊ शकतो.
हां
लाईव्ह आहे सर.
syllabus.pdf 661. त्याच्यावरचं syllabus.pdf. हां हां. Right? Is the audio clear? Okay, good afternoon, everyone. The subject that I'm offering for this particular semester is nanoelectronics. It's an open elective which is offered by the E&C department and has the subject code 18EC661. Now, as we know, every aspect of our life, be it personal life or academic life or business life, it is become heavily dependent upon electronics technology. And the specialty is that with each advancement in electronics, the size of the device is becoming small. In terms of performance, in terms of operation, the devices have become faster in their speed. And last but not the least, the power dissipation or the energy consumed by the devices has become very, very less. All this is possible mainly because of nanotechnology, as we call it. Nanotechnology or nanoelectronics is nothing but reducing the size of an electronic component in terms of nanometers. And most of you might be knowing that a few decades back, the computer was so used that it required a large room to be accommodated, whereas now, with nanoelectronics and nanotechnology coming in the fore, the devices have become very small. Now, at this juncture, it would be very important to know that all of this has become possible due to advancement in the CMOS technology, which has led to an increase in the size of memory, and also it has led to the faster electronics which is taking place or replacing the mechanical switches which earlier were operating on almost all of the systems. So as you can see, this is what I was talking about. The increase in the number of transistors or number of devices which has occurred over a period of time, that has doubled for CMOS every year, whereas in the past, the mechanical switches, they consumed or they increased in size only in about 5 years or up to 7.5 years. The applications, the scope for applications is immense. The diversity or the range of applications over which nanoelectronics comes into use is large. So as we know, the most popular or the most common is the computer hardware, display devices, mobile communication, audio products, cameras and films. All of this is possible because of advancements in what is known as SET, that is single electron transistor. And gradually that also has led to the development of devices which are called carbon nanotubes, CNT as we usually abbreviate them. Now more commonly or more recently, nano electromechanical systems, which was earlier called micro electromechanical systems, has also been gaining ground as the buzzword in the present technological era. So these are few more applications of nanoelectronics, that is the storage devices, optoelectronic devices, which help in conversion of energy from say solar energy to electronics energy, that is widely used in the solar panels, or in terms of LEDs where exactly opposite occurs, that is electrical energy gets converted into light. Quantum computing, where computers have become a part and parcel of almost the life of each and every person on this planet. Radios, which are used for communication in every aspect of everyday business, energy production and medical diagnostics. In India, nanotechnology has been taken up as an initiative by IIT Powai. It is also supported by Government of India, the Nano Science and Technology Initiative Mission. Whereas in other countries, the companies like Intel, HP, IBM, Kodak, AMD, Nantero have taken a lead in developing nanoelectronic devices. So this is a very brief, what you can say, sort of a summary table of the companies which are working in nanoelectronics. That is along with the Purdue University or Lucent Technologies, that is the Bell Innovation Labs. We have Intel, IBM, Seagate, and other organizations. I would like to emphasize upon the syllabus. Now the syllabus, the prerequisite for studying nanoelectronics is the basics of physics, basics of engineering mathematics, and the basics of chemistry that we have learned at the first year UG level. In general, the module 1 deals with an overview of nanoscience and engineering, but to be more specific, here we will be covering concepts related to the energy band diagrams, the various methods that are used for fabrication of nanoelectronic devices. Here we will also have a brief overview of the Moore's law, which has been predicting the reduction in the size of the electronic devices, and at the same time it is telling us about the increase in the number of devices or components which has occurred over the past few decades. Unit 2 deals with the characterization and inorganic semiconductor nanostructures. So again, I can say that Unit 2 is divided into two parts. One part is the characterization and second part is the inorganic semiconductor nanostructures. For the characterization part of Unit 2, we will be studying different techniques like field ion microscopy, diffraction techniques, bulk and surface diffraction methodologies. For the inorganic semiconductor nanostructures, we will first have an overview of the semiconductor physics, and then we will go on to discuss about the quantum wells, quantum wires, and superlattice along with the electron density of states. In all, Unit 1, Unit 2, they require a brief overview of the physics and chemistry that you might have studied at engineering, first semester of engineering. Unit 3, to be more detailed about it, deals with the fabrication techniques and the physical processes. Fabrication techniques like the epitaxial growth, semiconductor nanostructures, the colloidal quantum dots, and self-assembly techniques. Whereas in case of the physical processes, it deals with the resonant tunneling effect, the charging effect, quantum Hall effect, and other such effects which come into picture when we are dealing with nanotechnology and nanoelectronics. Now again, to give a brief idea, quantum Hall effect or the resonant tunneling effect, these might not be much of dominance once we are dealing with huge devices. But as we scale down the electronic components from micro to nano or still further below, these become very, what you can say, prominent or dominant in determining the the efficiency and the speed of the device. Moving on to Unit 4, we are dealing with carbon nanostructures and their fabrications. Here we will be looking at the carbon nanotubes and the applications, and also the fabrication of carbon nanotubes. Lastly, moving on to Unit 5, wherein we are dealing with nanosensors and their applications. Here we will look at a few applications of nanosensors like quantum cascade laser single photon sources, photonic structures, and Coulomb blockade devices, in addition to looking at the characterization and perceptions of nanosensors. Now again, at this point or at this juncture, I would like to say that we are strictly dealing not just with electronics, but also looking at a more interdisciplinary or a multidisciplinary approach, which involves even the mechanical aspects like the processes that we have just talked about, or even the phenomena which we have been dealing with so far. So this is what I would like to summarize. Nanoelectronics, it has resulted in the reduction of size, lesser power consumption, but a faster speed of operation with the complex integration of various circuits. There is a huge potential for breakthroughs coming in from the fundamental research, and also there is a lot of promises in the future with the enhancement of devices and technology, with every aspect of life becoming encompassed with nanoelectronics and nanotechnology. Thank you. Done. पेन ड्राइव इथे लावलाय का?
मला मेल ओपन करायचं.
इकडे पाठवू शकता का?
कुठे फॉरवर्ड करू का मी तुम्हाला? ओके. Sent. फॉरवर्ड कुठे ते? आर काय आहे? सेंड आउट केलं?
लॉग आउट आहे, लॉग आउट क्लोज टॅब करायचं. तुमचं लॉगिन करा.
माझं लॉग इन करते, फॉरवर्ड नाही करत. अय्यो. मी स्क्रीन शेअर मध्ये सिलेबस पण दाखवू शकतो ना?
मीट गुगल म्हणजे आता मी गुगल मीट चालू.
हा. न्यू मीट करायला पाहिजे का? Good afternoon, students. This is Professor Priyanka Joshi from Electronics and Communication Engineering Department. And I'll be taking up the IOE course, which is Internet of Everything, 18EC 664. So you must be asking me, ma'am, what is IOE? Because we have heard about IoT, but never heard about the IOE. So, well, students, I'll tell you this. IOE is a broad way, and the IoT is a subset of IOE. So there are many definitions of IoE, but we would go for we would go with the definition of what Cisco defines or Cisco gives us. The definition of IoE as the networked connection of people, process, data, and things. So as I have told you about the people, process, data, and things, these are the four main pillars of IoE. Whereas if we go with the comparison of what is IoE and IoT, then IoT refers simply to the network connection of the physical objects, basically, which doesn't include the people and process which we see in the Internet of Everything. So in this subject, IoE, moreover, we will be learning about the IoT only. So if I can say what is the primary difference between the IoT and IoE, then as I have told you, there are main four pillars in IoE, which is the people, process, things, and data. Moving forward to the IoT market map, you can see here there are n number of companies which work for the IoT services. And if I list you about the different companies of IoT, there are top 10 Hyperlink Infosystems, then LTI is there, HCL Tech is there, TCS Services, Kelton Technologies, TVS, then VVDN. These are the few top 10 companies which basically works and provides the IoT services. And if you ask me the top products of IoT in India, then there are many, amongst which you are using in your day-to-day life. So there are several top devices in the market which are basically working with the IoT, and they are the smart mobiles, smart refrigerators, smart watches, smart fire alarms, smart door locks, and the most attractive and the important and useful innovations has come nowadays, which are the smart bicycles. You must be have given attention to the Yana app, which are providing the smart bicycles which are semi-electric as well. So with that, yes, the IoT is doing lot and lot into the smart devices. So as of now, whatever I have told you, the IoT products or the applications of IoTs in different devices, there is a prefix as smart, isn't it? So the devices are becoming more and more smart. They are giving us a number of applications into the various fields. Then there is obviously the fitness tracker, medical sensors, smart security systems, and the list is endless. Now, if I give you a very good example of IoT, then I would like to ask you a question, that is Alexa an IoT device? Well, I'll answer this that yes, Amazon Voice Assistant Alexa is one of the most comprehensive IoT service which can control more smart home products than Google Assistant or Siri, basically what we know. So Alexa is present in the Echo device, which controls the smart home, the different devices, so which is basically working with the IoT and cloud. So moving forward about what is broadly IoE is. So on the screen, you can check the four pillars of IoE, what initially I have told you. So it started with the people, the connection of the people in relevant or more beneficial ways, which goes to the process of delivering the useful intelligence from one point to the next. And this process uses data, which converts the data into the intelligence and allow for better informed decision making. And this data again is being implanted to the things are nothing but the physical devices and objects that feed data into the internet of everything, and this utilizes the data to perform the particular actions. And these things again are being used by the people for their relevant or specific application in a more beneficial way. So as you can see, it works in a loop. People process data things again to people process data things. So this is a endless loop, and it works beneficially and gives more effective results than the physical IoT devices. The prerequisites are nothing more. Here I have explained you about the Python skills are required, but we have like amended the syllabus, and this is a more theoretical approach we are having into the contents of the syllabus. So in this course, basically the 5 modules are distributed amongst the introduction of IoE, wherein you will be learning about what is IoE, and then the comparison between IoE and IoT, the characteristics of IoT. Moreover, there is 80% of IoT only in this course. Then the second module is about the smart objects, in which we will be learning about the smart sensors, the cloud technology under IoT, and the different sensors which are useful for the different smart electronic gadgets. The third module is of IoT applications for industries. You must have heard about IIoT 4.0, which is the industrial IoT, the IoT which is very much useful in the industries. So few case studies also are there, which we will be learning under this module. The fourth module is about wireless sensor network. So we will be learning about what is wireless sensor network and the different layers of OSI model, which is basically using in this WSN network. And we will be learning about the few protocols, IEEE protocols here, which are very much useful for the network connections. And the last module is about the IoT privacy, security, and governance. So this is more on application based, more on to the security based, privacy based, and few case studies are there which we will be looking forward into this module. So these are the 5 modules basically, which we will be looking into this, or which we will be studying into this IoE course. So there is one video. I would like to play this video. So I guess this is not playing enough, but lastly I would like to tell you that the future of IoT has the potential to be limitless. You can see that nowadays we are using 90% of the electronic gadgets all around us, whether we can say smart home electronics, consumer electronics, mobile phones, and smart trackers, smart fitness bands. There are a few special bands for visually impaired people. So the different innovations and different ideas are coming up into the IoT, and I can say the potential into this IoT is really limitless, and the companies are moreover looking forward into the IoT professionals. You have a very good scope into this field, so I request you all to take up this course and learn about the new technology which is required into the industry. Thank you. झालं ना सर? स्टॉप पण झालं ना? हा, इथे पण काहीच नाही आलं. इकडे काहीच दिसले नाही माझी पीपीटी.
इथं
दिसले ना?
काय मॅम रेकॉर्ड
इकडनं साइन आउट करून द्या आणि हे पण क्लोज करून टाका माझं पीपीटी. आणि हे एक व्हिडिओ प्ले करायचा होता मला.
Hi all, I am Akash Bhosle, an alumni of GIT, currently working as network engineer at Cisco. Today I am here to talk about IoT, that is Internet of Things. I personally define IoT as a time efficient technology.
लेट इट बी. मी ते गेलो होतं ऍड, पण ते प्ले झालं नाही तेव्हा. Thank you so much. झालं ना? Sign केलं.
ठीक आहे.
बघायचं असेल
Meetings. Aashish. Where is that PPT? Can I disable this one? Start करेंगे सर. अभी आ रहा है, दिस PPT आ रहा है क्या? चेक कर. Okay. Good afternoon, students. My name is Dr. Manjunath Mangudi, Associate Professor, Department of PCA. And today, this time, I'm going to handle for the artificial neural networks. And subject code is 18EC662. This is a professional elective. This subject, especially for the present technology, for the new trending technologies, and how they are going to use in the artificial neural network in industry. What are the job opportunities available for industry in across the country? We will see now. See here, we all know what is that artificial neural network. There is a networks. Two basic reason we are going to building, either it may be, you can take the brain. In the brain also there's some nerves is not working, neurons is also not working. Through artificial neural network you can find the which in particular which area neurons is not working. In the same thing they're going to use in the industry also, artificial neural network, in the based on the technical as well as biological viewpoint. In the technical viewpoint, some problems such as either they're going to use in character recognition or prediction of future states of the system required, and parallel adaptive processing. This is for they're going to use in a technical viewpoint, and they will take some problems and also they're going to find the characteristics. That is nothing but either it may be neurons, either it may be any character also they can find, and also you can predict it further by using artificial artificial neural networks. In the same thing they are going to use in the biological viewpoint. In artificial neural network can be used for the replicate, simulate components of the human or animal brain. They're giving to the insight into the natural information processing. You can collect the information for the particular brains, and also either it may be human brain, either it may be animal brain also you can analysis by using ANN. Now see here, information just you have to transmit in the series of electric impulses, that is called as spikes, and also you can find the frequency phase of the spike encoder information. And also you can see in the biological system, one neurons can be connected to the many 10,000 other neurons, and that is also you have to predict by using the ANN. Now in the present market you can see here, every market they are going to identify the based on the application for the Indian agriculture, and also they are going to use it in the smart farming future also. Now you can see here in India they are going to use it in ANN satellite mapping, electronic marketplace, livestock traceability, climate sensing station, and product traceability, agriculture drones, and also smart farms. These are also application they're going to use in the ANN. And here by using the artificial neural network, there is a job creation in the agriculture field. Now you can see here in the field workers, you can imagine how many people is required for the train ANN, and also drone flyer, data analysis, agri quality certifier, warehouse manager, geotagging, and software application developer. These are also they're going to use for the artificial neural network in the industries. Now you can see, and there is a main in agriculture quality factor there is required for the domain expertise to accessing the agriculture product quality as well as the price. And also they can find the what are the data mining they are going to use in the management, either it may be certification also, that is also they can use. Now you can see here in the market across in the 2022 and 2023, almost in all the application they are going to use in the artificial neural network. Now you can see here in the artificial identified AI based application in the Indian healthcare system, there is a remote medical assistance. If someone is sitting some village places, he needs some assistance for the medical, immediately you can provide with the artificial neural networks. Either you can use to the smart diagnosis, cloud based eye screening, preemptive diagnosis, smart ambulance, or also they can use to the emergency care, medical record digitization, smart consulting. These are also applications they are going to use in the Indian healthcare system. And the same thing they are going to implement it in the job role for the healthcare domain also. If you learn for the ANN, you can imagine there is a huge opportunity for especially in the healthcare domain. And also you can see here in the India in the healthcare ANN as well as IoT market, there is in a 2028 agriculture and healthcare domain, 18% of Indian IoT market. You can imagine everywhere it's required for the artificial neural networks. Transportation also is required, automotive, healthcare, retail, agriculture, and also others is also required for the, this is a market analysis for the artificial neural network. Now in final conclusion, and the neural if you learn from this subject, finally you can understand what is the artificial neural network, how they are going to use it in the each and every application. Either it may be neural networks also contribute to area of the research, neurology, psychology. They are also regularly used to model parts of the living organization and to investigate the internal mechanism of the brain. Second conclusion, many factors affect the performance of ANN, such as the transfer function, size of training samples, network topology, and also you can adjusting you can use to the different algorithm. This is the main thing you are going to study for the artificial neural network. My point of view, if you study this ANN, it is very useful for the career in the present industry, and every industry people they are going to use it in the artificial neural network. Thank you.